Thank you guys for having me. So, as the topic suggests, so this started with Django. It's now available in Flask and Node.js as well for anyone who's curious. But for this version, we are going to be talking about Django itself. The structure itself is kind of similar in all the different versions. So I'll kind of go with this, and that will kind of make sense in the other ones as well. So I actually kind of believe that security needs to be open source in terms that there's a lot of solutions out there that are paid. And if you're a nonprofit or a early stage startup or even just a student, sometimes you cannot even afford the enterprise level security. So that's where AIWAF comes in place. Now, in a lot of proprietary WAFs, they're pretty much black boxes. You cannot see their logic, and without seeing their logic, you're supposed to trust them blindly. So, and that's the problem here. I mean, there's not a lot of community solutions in terms of firewalls. So that's what AIWAF is there for. And the idea is to get more collaboration on this project. And this project is actually sponsored by DigitalOcean in terms that they kind of pay for the website. So you can check out the website for this later on. So AIWAF is literally AI Web Application Firewall, and this has a middleware level security, so which makes it highly customizable for any one of those who have used Django before. So I'll be going through each middleware and then kind of be going through what each middleware does, and then how you can add it on all in the later. So header middleware. So the main idea of this middleware is to detect bots and malicious requests, and it blocks suspicious traffic before it even reaches your app. This is not ML in any case. You're not really training a model. All you're doing is that you're looking at different aspects of the header and kind of making a decision whether this is a bot or whether this is an actual person. So in a lot of cases, if you use curl, then you would notice that if you have ever examined logs, you would kind of notice that in a curl request, a lot of header aspects would be missing. But if you look at a normal browser request, you would see that there's a referrer, there's a user agent, and that's what this middleware evaluates. So if anything looks like a curl, it blocks it out outright. So that's what it's there for. So it kind of provides you an early protection against scrapers, scanners, and bad bots. If you have malicious or broken clients, for instance, if you get a request with partial or missing headers, then it ends up being blocked outright. And I'll kind of go through an example on how that works. So the IP address here, I kind of changed that, but everything else is pretty much from the web app I have hosted on. So you will notice that in the first example, I'll kind of go example by example. In the first one, you have everything on there. You have your client IP address, you have your timestamp, you have your request, and then you have your status code, response size. So this is how it's supposed to look like. And I'll show the malicious one on the next one. Okay. So in this one, you would kind of notice a few things here going on. So in this case, you have your client IP, you have your timestamp, but you would notice that it's kind of tracing back to a PHP file. And we know this is a Django app, so that does not exist. And there's also no referrer and no user agent, which is also a red flag, which means that someone curled in right on the IP address to kind of find out whether there was a broken file or a PHP vulnerability. I assume they were assuming a PHP app, and you will notice that this was blocked very quickly in 54 milliseconds. So that's what this middleware does. If you have your user agent and referrer missing, it blocks it out outright. Now, of course, you can add exceptions in your app, which can be customized. You can set that some IP addresses could go outright through this without any block. So it's always customizable. and the next one is IP and keyword middleware. So the way this WAF actually started on was this was the first middleware, and in this case, now IP blocking isn't every middleware, so this is more of a keyword middleware now. But in IP blocking, all you're doing is that you're checking your block list and seeing whether an IP is already blocked. If it's already blocked, then there's no point of wasting resources. And if it's allowed, then it goes through the other middlewares. And so the keyword middleware is actually where you would see some aspect of ML, and this is where the ML actually comes in place. So this actually uses multiple signals. So any keywords that are not being hit by a 404, it kind of creates a list on there. So like in the previous example, if you have a PHP, or if you have any other aspect that is not on your website, it stores it in a list, and any request to that specific keyword, it would block it outright. And so this is a context-aware detection. So the same keyword can be safe in valid routes and malicious in attack context. So in this case, we are considering whether there's a directory traversal attempt, or a suspicious file probes, or non-existent paths. And the idea is that you don't really block based on one thing, but you're looking at a variety of aspects before deciding that, okay, this is suspicious and this needs to be blocked. And in the beginning, there was a lot of problem with false positive, in terms that it would block out valid paths, and that's where I kind of reduced the scope a little bit to make sure that it's only looking on 404s. In terms that if you have a valid route, then it won't even look at it from a keyword perspective. It'll only look at the keywords for when there's a 404 or multiple 404 attempts, and then it will scan the path and keywords, and it will also make sure that that keyword is actually not in your Django app before adding it into the block list. So a part of this project is actually trainable, and the part of this project is adaptive learning, and the focus long term is adaptive learning, and this is one of the areas that pretty much does it well. So in this case, keywords actually accumulate throughout traffic. It's not like you have to run a trainer script every now and then to kind of make sure that your app has all the keywords in the keyword list. And the idea really is that you don't really have to dedicate more resources to make sure that you're training every once in a while, and you're also not blocking valid application routes. Rate limiting is another.
Wait, what is a keyword?
Keyword is, so for instance, if I am trying to go into a PHP, right, a PHP file on a Django app, that is a keyword. Now next time whenever somebody goes through that to that specific PHP, again, if someone else goes to a PHP file, then it will know that, okay, this is a suspicious request, I need to block it.
Right.
So that's a keyword.
Okay.
And
making the assumption that the attacker doesn't know it's a Django app.
Right.
Okay.
Right. Now PHP is just one keyword. I've seen a lot of other ones. There's some people try traversing for env files as well.
Mm-hmm.
And as we know, that is also not really visible through Django. So that also has ended up getting blocked in various levels as well. A lot of other examples too. Basically anything that is non-Django and someone tries to use that to find out attempts, we already know that it's a malicious request. So it ends up blocking them outright. So rate limiting is basically for DDoS, where if you're getting more than a specific number of requests in a slider window, then you block them outright. For instance, in someone tries a denial of service, then usually what they do is that they'll flood your server with a request, and you have a soft limit and a hard limit, and I guess the logic is on the next screen. So if there's a flood limit and then there's a max limit, if you make it through the flood, then it will kind of raise a error, and then if you make it through the max, then we'll kind of record your IP and make sure that you cannot get in again. And the idea is that it kind of looks at a specific interval, and that is actually customizable. You can set maybe 2000 milliseconds or any window of your time, and then it will correspond to that. This is actually common in most of the Web Applications Firewall, and this is actually the first middleware that was actually in AIWAF.
Where's the AI coming in this? I feel like none of this stuff requires AI.
It comes in later, especially when we train an isolation forest model. So the word AI doesn't really imply AI models specifically. It involves a lot of looking at machine learning, if that makes sense.
You said adaptive learning?
Adaptive learning.
Not necessarily neural networks, but...
Not necessarily. If you run a neural network, it will basically slow a lot of things down.
Yeah.
Right, you gotta... Right, exactly.
Well, I'm thinking AI in this very broad category of like, well, a random forest, still AI, k-means,
Right.
still AI.
Right, so we still have...
Regression is still AI if you want to be very general about it.
Right, so this actually uses this actually does have an AI model, but at least in the web apps I use, I kind of made sure that it only trains when there's an actual, when you have enough logs to kind of train it on, otherwise you'll have a lot of false positives.
Okay.
And we use the isolation forest model. I'll kind of go through that in the AI middleware. So then there's the geoblock. This was actually recommended by a company that was using AIWAF, so they wanted a geoblock as well. For life of me, I don't know why they would want to block a specific country, but I guess they probably do. So
China wants to block all the traffic are going to North Korea attackers.
Right.
Well,
Right.
if it's like a back-end service, sometimes, you know, when people they'll do forensics for like business email compromises, they'll see, oh, well, somebody logged into your Exchange server from like Africa,
this, right.
and you're in Ohio.
Right.
It's probably not.
That's probably why. That's probably why. So this one actually kind of took some research in terms that I actually had to find the actual MMDB file because it's not widely available anywhere. So all this does is basically it looks at your IP address and then it kind of searches through the MMDB file to kind of see where you're kind of requesting from. And basically if you're from the allowed if you're from the block countries, then it basically doesn't let you through. But you can set up exceptions both ways. You can have an allow list or a block list, for instance. If you want all requests from this country, then you can do that too. I don't think anyone would use that ever, but it's there. So yeah, that's basically how you use GeoIP middleware. So basically you have it in cache to make sure that you're not repeatedly looking up in the database, and so we use a lot of caching in this one, and this is basically just looking up whether the request is coming from allowed countries or not. So like I said, this is also configurable. You can enable parts of it, enable countries or block countries, and if it's allowed, then it allows everything in it, but if it's not allowed, then it blocks everything in it. So kind of allows restrictive and selective geographic policies. Now you could always have a VPN which could bypass it, and I'm kind of seeing how you would kind of navigate through that. I don't really see a way how you could navigate it through it, but anyways.
I mean, like, is there a way to do it through VPN?
Well, if you connect to a VPN, it will change your IP address in the first place, right?
No, I'm saying, like, can you learn the locations of the IP addresses originating from, and then block those IP addresses?
You could, but
That wouldn't be a
guess-
geo-based.
Right, that wouldn't be a geo-based though.
And it would be an ex post facto thing. It wouldn't be a thing you could do live.
Right.
It would be a thing like the NSA would do. Like, you know,
Well,
after the fact.
Well, a lot of, for actual advanced threats, they have what's called residential proxies, where they'll like have a botnet of people's routers they hacked. So you can't really necessarily block those, because that's just, you know, people's houses.
You can just use the EC2 instance too, spin it up anywhere.
Well, I just want to know how easy it would be. How easy would it be to find out the origins of the VPN servers that's accessing?
Well, your users might have VPNs too.
Like, because you know you connect to a VPN tunnel, right? It has to eventually come out of the VPN somewhere.
it comes out of the VPN endpoint.
Mm,
You can usually tell what network to be.
that could be it.
Nobody's like, you
You can say, oh.
Right, this VPN equals false.
I don't really know.
Yeah.
Doesn't masks, like,
Or you could
VPN,
set
let's
up
say
a
you could
proxy
use
server too.
Mhm.
this device is the VPN.
I
Right.
don't know how VPNs work,
Device
well,
IP,
but
it's
I'm like imagining that there's like some
Right.
machine
Like the device
that
IP.
exists.
So all it looks like is IP address.
And that's
So if you're using a VPN and if you're at any part of the world and somehow this blocks it, you still be safe because you're using a VPN that's based here. So this is only assuming nobody uses VPN.
Location of the box in the middle.
Right.
Well, you can. That's the point.
So-
It has to go there, yes.
So then why can't you block the IP of that box in the
You
middle?
can. Oh, yeah, people do that all the time. Totally.
Right.
Yeah, I did.
You could. You just need to know the IP address of that box.
If they're
This-
for all the legitimate users of that
That-
VPN.
I mean, that box, I think the point is just, if you have what's called geofencing, that box will show up inside your fence.
Are there?
Yeah, but I'm saying like, can you like, wouldn't there be a way to detect like, say, well, this
No.
user's VPN, I want all VPN.
Yeah, but that wouldn't be geofencing, that would be a different
And then you
heuristic.
can look up.
Not in headers, because all it looks at is the IP address.
I know, but like just generally speaking, like, is there headers, request headers
Blocking it
from
by
VPN traffic that would like,
somehow, you're just saying, okay, this offset is done by like.
No, because all the headers would tell you is where the request is coming from and request size, and that's it. Doesn't really tell you anything about the VPN.
If you've never had
That's the beauty. I don't know how Netflix knows it.
explorer header.
geofencing,
No,
like actually relies a lot.
as far as I know, no.
You would be surprised.
I don't know how Netflix knows it. Because one time I knew they had a. There's gotta be something. I don't know how,
Well,
but there's gotta be something.
Blocks before
do we want to get to the rest of your slides?
Oh yeah, there's 50.
Okay, let's take a time out.
Yeah.
Come back to talk.
I really wanted to track them where
Yeah, basically, now we are in the AI part. This is where the AI of AIWAF really is. So in this case, we use an isolation first, and right now I'm kind of switching it to Rust as well. And it works great because I'm trying to make sure that I can port the same logic to JS. And creating an isolation first in JS is very hard. So I'm kind of making sure that we have a centralized Rust library that is used by both Python and JS, and even potentially PHP versions, and we can port it to PyO3 or WASM for web-based deployments. But anyways, on to how it really works. So what it really does is that it looks at your logs and kind of looks at all these, collects all these patterns, and it will look at 404, burst behavior, status code, response time, and then the idea is to train on behavior patterns and not individual logs, because you're not going to get anything out of it. And essentially we want to block based on behavior aspects, not essentially where the requests were going. And if you don't have a lot of logs, chances are that this will end up blocking even the legitimate traffic. So right now what it really does is that if it flags something, then we actually evaluate through a predefined logic, whether we really want to make sure that something is really malicious before it ends up getting blocked. So if an AI anomaly model indicates that, okay, this is malicious, then we analyze the last 5 minutes of behavior, and then we kind of make a decision on whether or not to block. And in this case, we to kind of make a combined decision, we kind of evaluate patterns like repeated scanning, high concentration of suspicious words, and burst traffic patterns, or even traversal attempts. And the idea is that if you have a really active user, you don't really want to end up blocking them because they'll have a high activity, but you don't really want to let the legitimate blocking traffic to end up getting passed as well. So you have a combination of two things. You block, you understand whether a request is malicious, and then you kind of see whether you actually have to block it or not. So like I said, exemption applies at every stage. So if you have an IP that you want to let through, it will make sure it always gets through, and that happens in every middleware. And the idea is that it adapts over time without compromising stability. Now, unlike the other middleware, this one has to be trained every now and then, and I'll kind of get through how often you have to train it to kind of make sure that your model is up to date. So we use an isolation forest model, and what it really is that I actually have a nice analogy. So it really fits like a needle in a haystack analogy. So the way it really works is that it will kind of figure out the architecture really figures out what really stands out. So if you have a lot of data, then your anomalies would be more realistic, but if you have a lot less data, then it will flag out everything as an anomaly. The really great part is that you don't really have, it's unsupervised and it's efficient. I mean, on web request, even if you use the isolation forest model, it doesn't really slow down your request that much, or to any observable matter, as a matter of fact. And it's simple to retrain. All you have to do is rerun the script with your logs, and it will adapt to evolving threats. Now there is a little bit about how often you have to train, or whether you want to train at all. That's another point, because so based on traffic volume, you'd want to make sure that you're training. So if you have more data, you would have more frequent training, and if you have fewer requests, then you really want to evaluate whether you want to use this middleware or not, because if you don't have a lot of data, then this will lead to a lot of false positives, because I don't really have a pre-trained model, because I don't really have a million requests that I can train it on. If someone does have million requests, just let me know. I'll kind of train it based on their logs, and I'll kind of package it as part of the Python PyPI package. But yeah, like I said, it's pretty much a linear relationship. If you don't really have a lot of requests, then I would really advise against using this specific middleware. But if you get a lot of requests, then you can even train daily. If you get 1 million requests, that'd be fantastic. And but you don't want to overtrain as well, because because you really want to have something significant before you kind of retrain, because training is expensive. You don't want to waste your compute on that. So that is the AI part of the AIWAF, and there's more middlewares as well.
Does it only use the one model, the isolation forest?
Oh yeah, I tried with other models as well. I mean, for one reason, I could not find a faster one, and for second, I mean, I couldn't really find anything with this level of hypothetical accuracy. I mean, because what you really want to be looking at is if something stands out, right? So in theory, I mean, you either need a model of this specific type, or any neural network would potentially slow down your application. I'm still experimenting on more models, but so far this is what I've come from.
A model that understands what a bad pattern is, rather than trying to detect an anomalous pattern, just have an understanding already what perhaps a SQL injection or path traversal or cross-site scripting would look like.
It sounds like you're using a transformer model there, right?
Right, but that would slow things down, right? Because
With like pretty modern, quantization that can actually throw some.
I mean, you kind of have to assume that not everyone is kind of using a all the way. I mean, at least the machines I use, they're not all the way to the top CPU level. If you have someone that is using EC2, micro, or maybe even free tier, you don't really want to slow things down. So anything like a transformer model would slow things down a lot just from inferencing. Unless you have a GPU engine, then it could be different.
So are you able to plug in whatever model that you want to plug in?
Not at this point. It comes with isolation first.
Okay.
Yeah.
So with the isolation force, are you training it what good traffic looks like, and then it finds the anomalies, or are you training it like what bad traffic looks like?
Well, it's not really training on traffic. It's training on behavior patterns.
Okay.
In terms that you kind of gather a IP specific data, and then you kind of say that, okay, this IP hit that many 404s, that many burst requests, and that many valid requests. There's a few more things on there, and then you kind of get a lot of data in that format, and then you kind of say that, okay, which one stands out in terms of malicious 404. And the best part about that is the part that stands out is likely going to be malicious, but not always. So you could have a really active user, just someone who forgot their password, just clicking on login, because that actually happened to me and it ended logging me out. So that is one thing that it really leads to false positives in. And so that's why I said even if you can spot anomalies with the model itself, you still have to have some kind of logic that, okay, let me check whether this is actually malicious or not.
So is it being fed like time series data per IP or per session?
Not time series. It's basically a
Per events?
of events. It's per IP data in terms that in this IP how many 404s you got, how many malicious 404s you got. Not really sure whether this would be accurate time series, but it's more or less like a CSV format file or a JSON that it kind of looks at, and then yeah.
So how does it know what ground truth is? Like how does it know?
It doesn't. That's the thing. It just looks at what is the. It just looks at, okay, this is the part that's standing out, and this is probably malicious.
Okay, it's look like.
But what does standing out mean?
So something with a very high 404, something with a very high, I mean more than normal. So if let's just say your 404s per IP are at probably 8 or 9, right? And if you get 50.
So it's looking at the error response code
Error response codes.
as a kind of ground truth.
Right.
Yeah, if you ever like really look around your log, you'll see a lot of scrapers will be like, oh, hey, let's see a WP admin or all kinds of
Right.
stuff, you know.
Right.
But all that gets caught earlier than this one.
Right, exactly, because that gets blocked by the header middleware.
Yes.
Because you don't really want to get to the AI part unless nothing else stops it. Because I mean, there's so many. I mean, at least for the scrapers, you can quickly see that, okay, they're. I mean, they have a lot of a lot of header strings missing. So it has to be malicious, more or less, unless you end up explicitly whitelisting it. But yeah, I mean,
Those are also the easiest ones to block.
those are also the easiest ones to block.
So is it using the easy ones to block as part of the training?
No, because if it gets blocked, then it gets assigned a 403, and it only looks at 404, not really 403. Because I mean, if it's already blocked, then you don't really want to be training on that. You only want to be training on patterns that are not blocked by the other middlewares, and second of all, that are valid traffic.
I see.
So only 404s. Now the idea is to add more patterns on there, and honestly also to come up with a model that could detect behavior patterns. For instance, if someone is running a scraper, then it has a certain pattern, or if someone is trying to understand vulnerabilities, and that has a separate pattern. So that's the next goal of this particular AI anomaly middleware. But anyways,
Real quick, the isolation force, that's deterministic, is that right? It's what it looked like?
deterministic. That's what you said.
Yeah.
I mean, how do you mean deterministic? I'm just trying to understand.
That for the same input, you will always get the same output depending on the training or the structure
right.
of it. But as long as you're within the current force model that you have,
Right.
yeah.
Yeah, it would really have, yeah.
Okay.
Same input, same output. Because I mean, yeah, if your data is exactly the same, then always the same same rows would stand out in that sense. So yeah, you're right. It will always, it's kind of deterministic. But that's why I said, I mean, if you keep on retraining it, you know, based on little to no data, then the idea is it's not going to learn a lot. So that's another thing to remember in retraining. You only want to retrain when you have more than enough data. Now, honeypot timing middleware. Now, this actually came with the honeypot blocking on the form itself. I am actually recreating that, but right now there's only the timing middleware. In terms that, in a lot of cases, even if you have well-planned bots, usually in some cases you would have bots also send post request on get request pages even if there's no form to identify whether there's a particular vulnerability or particular gate they could extract or exploit. So this is where this comes in. So the basic idea on how it really works is on get request it stores timestamp, on post request it measures time difference, and if it's too fast, basically less than 1 millisecond, then it's likely a bot. If it's too slow, then the chances are someone abandoned their own form and it's an expired or a stale session. Now, based on feedback I got, this usually applied to everyone, but if it was an authenticated user, it usually exempts this particular middleware because apparently the company that kind of told me to make that exemption was they had multiple people using the same account, and somehow for some reason they were submitting the same form, which made no sense, but kind of seemed like an interesting use case to factor into. But yeah, so if you're already logged in, it won't really look for any of that, but if you're not logged in is when it actually checks. So this is really important because in a lot of pages, I mean, if it's submitting really, I mean, if any of you has contact forms on your websites, this is where it probably comes in. I actually have a website for a non-for-profit, and we do not get any useful inquiries on that form except from ads or maybe scans, or one time somebody said that we hacked your website without any proof. So that was interesting. But the idea is to reduce the false submissions of forms using bots or scrapers, as a matter of fact. So this is what I really was talking about. If you have a page that only supports GET request, it should only be getting a GET request. And if someone is actually trying to find out where the website has any kind of vulnerability, chances are they're going to send post request or put request, delete request to get only endpoints, or get request to post only endpoints in order to exploit your particular web application. Now, this particular aspect is where this becomes really helpful, is it will block those specific attempts, in terms that if your web page only supports a GET request, it will make sure that it only gets a GET request, and if any other method tries to, if anyone else tries to use any other method, then it would end up blocking the request outright. And this is really helpful for advanced vulnerability scanners, because this is what they basically use to find out where things might be missing. So like I said, authenticated users always pass timing checks on forms, and exempt IPs are never blocked because I occasionally test a website, and this is something I always try to break it. If anyone else can try this out on their web server and end up figuring out where it breaks, let me know, I'll fix it before I give the talk at PyCon. And then there's additional behavior. For instance, if you end up with an expired form page, chances are someone put it stale and it sends a 409 on a return reload request. And the idea really is that blocking only happens when there is a clear violation. If someone's logged in, it doesn't really look at the timing logic. And if someone is only poking around your website, then only it will block that specific instance. I believe this is the last middleware. So UUID middleware is basically, it protects routes that use UUID parameters. There's two aspects to it. It will kind of make sure that whether your app has that specific UUID in your application, and it will also make sure that that UUID is also valid, which is also important because if someone tries to misuse it, chances are they're going to jumble up UUIDs and try passing it on the on your specific application. So the idea is to prevent users from altering identifiers to gain unauthorized resources. Now how it really works, it works at view resolution time, looks for UUID parameters. So if no UUID is present, does nothing. If it is present, it will validate against matching models in that specific application. And it only activates on routes that actually use UUID based object lookup. It also looks at whether there's any kind of UUID backed models for the current app. Looks at primary key fields or explicit UUID fields. If that does not exist in that specific app's model, chances are that someone's poking around, so it ends up blocking them unless otherwise it lets them through. Yeah, so it also makes sure that that UUID is also valid in terms of validation.
This assumes it knows that the REST endpoint refers to a specific model in the database.
Right, so if I am going to that specific app, it will look at that specific app's models.
Yeah.
Yeah, that's how it
Depending on
works.
how fast or slow that is.
Right.
This is possibly an issue.
So,
You gotta use it right.
right, so there's another aspect. Initially there was a cost issue, but it will only look at objects that are already in cache itself. So it will cache out the UUID specifically, and then it will look, just to make sure you're not slowing anything down by constantly interacting with ORM. Now, if someone ends up sending an invalid UUID, they get blocked outright, and you kind of make sure that it's not doing a costly lookup anytime. Because if your application slows down, chances are your WAF is not doing very well. So if, like I said, UUID does not match a valid object, it returns a 403 and it blocks through the block list.
But doesn't it still have to run that query to know if the UUID is valid? Like
Could you repeat that?
What's the difference between saying, oh, the UUID is not found versus it's not a valid object?
Well, so there's two aspects. So first it checks for validity in terms that whether that specific UUID is actually valid, not in terms of the models itself, but in terms that can this specific UUID can actually exist. And if it exists, then it will kind of look into your database. Now it is kind of too harsh for now, because if it does not find it, then it will end up blocking it. If it's not in that specific app's models, then we'll end up blocking it outright. So
I
yes,
guess
it
when
is.
you say, so that says valid object, but I guess when you say valid, so you're talking about like syntactically,
Mhm.
like this is a well-formed UUID?
So well-formed is one thing, and then does it exist as well?
Okay.
That's another thing.
But if you're checking for whether or not the UUID exists, that's still like, that's the same thing as saying get ID equals this UUID. You're still doing a database query.
Well, not all the time. So you cache it. So instead of looking through the database every time, which makes it very expensive, you cache UUID objects in the cache itself. So which prevents expensive lookups. So the idea is really to check whether, first of all, can this UUID actually exist, and then actually searching for it in the cache. If it's not in the cache, then it will look up in the model, but that's how it works.
I get that, but that doesn't seem like it's like a security logic. That's just an application. Does UUID exist in the system?
Right.
So
that's
if you're
literally
saying
what it
If
is.
you have something that's just fishing around for UUIDs, it's
Right.
probably bad behavior, so.
Right. So that's how it works. yeah.
Okay.
But there is the other side where you have a valid user that's just got bookmarks there or something, they haven't hit it in a month, that UUID no longer exists, has been cleaned out of the system.
Mhm.
They try to use it, that UUID doesn't exist, they are blocked, and that's kind of a poor user experience, although I would personally argue that's valid, they got blocked.
Well,
But
I
it's
guess,
still
Mm.
something you gotta plan for.
I guess you wouldn't configure it to block it on the first one, but if you have like a rolling window or something that's intense, like if you're just trying to launch bam, bam, bam,
They're
that's
still
probably
gonna get,
malicious.
they're still gonna get 403 right
Hmm.
there. Which I'd still argue is valid, it's just
Yeah, yeah.
the other side.
Right. So the idea really was the way it really originated was I actually ended up finding a vulnerability when I was using just IDs on my application, in terms that if I changed the ID, it would basically reiterate to someone else's account. So the idea is to block that kind of behavior, but with UUIDs. Now, with that being said, if someone loads up that exact page and ends up getting blocked, yes, there's a chance. And the better model would be to say that instead of blocking at one time, you look at their behavior and see, okay, does this user look suspicious or not? If they look suspicious, then block it.
Okay, so if somebody's trying to do like ID enumeration, or
Right.
UUIDs, if they think it's like the time series based one, where it's like, okay, let's just keep trying the next millisecond.
Right,
So on.
right.
And like,
So there is a way to like kind of guess which UUID is going to be valid.
Depending
There's
on
like so many-
generally,
yeah.
some of them are completely random and some of them are time based, but I think like there's like 4 different types.
I think that the OWASP people would consider this a BOLA or broken object level authorization. So you do want to make sure also if people do guess a valid one, but they're not actually so you do guess account that exists. You also need authorization in place.
What are
That's not necessarily a firewall
That's not
issue. That's an
necessarily.
application
I was
logic
like-
issue.
Right.
Technically,
Yeah.
theoretically impossible to guess somebody else when you such a big.
I don't really think it's possible to guess.
Well,
You can intercept it, but you can just guess.
You could, yeah.
yeah.
You have to be hard.
But wouldn't that be in HTTPS issue if someone intercepts it instead of
Yeah.
a firewall thing?
some ways.
Yeah, I leave
Unsafe
written
Wi-Fi.
UUIDs beneath my keyboard all the time, man.
Yeah. So anyways, that's basically all the middlewares, but the idea is just to expand this logic to different web applications. Now currently it exists in JS and it exists in Flask, FastAPI, and Django as 3 separate projects. I'm trying to make it into a single repository in terms that you can consolidate a lot of the code instead of replicating that on every single web application. So that's where the framework consolidation comes in place. Now, a lot of logic has been, not a lot, but the compute heavy logic has been ported to Rust. So the benefits of that is, I mean, for PHP, all I have to do is translate into a PHP version. I'm not really sure how I would do that from Rust. I know there's a way, but can't remember on top of my head. What?
Have you thought about doing something like having it as I don't know, it's like a sidecar process or something that kind of sits between the application and say like, I don't know, Caddy or.
Well, not really, because
Well, the whole point of this is that it has to be in the application.
Right, it's a WAF, right? So it's an application level. And second, I wouldn't really know how to do that.
Yeah.
So,
You consider like a hot fix
uh,
feature. So say like a CD comes out, a vulnerability, and it has a very specific payload to execute it. So the maintainers of the site can just easily add that to the block list.
well, so in terms of CB, in terms of Django, I did not see a lot of things. But now that I was moving to JS, I see that they have a lot of, and they have a really good documentation on terms of, okay, this specific version has this specific CVs in terms of vulnerabilities, and this specific version has this. So I'm looking into it, and that is something I do want to address. But currently, it just looks at these things. Yeah, the other thing is, like I said, smarter AI models. I'm not really sure what I would use instead of isolation first, but if anyone has any ideas, I'm always open to suggestions.
Have you looked at doing anything like WebAssembly?
Well, the isolation forest for JS, right, it works in WebAssembly.
Oh, nice.
So the main problem was when I was porting things to JavaScript, I tried writing the isolation forest, and I did succeed, but it's just that it's very slow. So if it cannot load the WASM module, then it loads the JS one, but the WASM one is actually the specific thing, and in the scoring model for header middlewares actually works in Rust, in terms that the only Python thing is is not going to be anymore, would be the isolation forest, which is going to be Rust based now, and the ORM specific patterns. The idea is to port as many things to Rust as I can, but to make it Django specific, you can only port so much.
What logging does this have?
So it looks at your, I'm not really sure how would I pronounce it, Nginx logging, and actually there's a middleware. If you don't have logging, just turn it on, it will start logging by itself, and then it will look at those logs if log path is not already set up.
And
So it's looking at Nginx logs?
It looks at Nginx logs.
okay, vice versa,
Mhm.
what does it log in case of pass or fail, especially on fail?
So when you say pass or fail, do you mean blocked or?
Block or yes?
Well, if it's blocked, then all it would say is 403.
What do you log internally?
Just 403.
Well, I guess, is it possible to have just a separate log stream for this?
Yes.
You could. Actually, that's a good idea. I did not think of putting that in. So yeah, I'll put that in.
I have a question. Have you considered threat intel for the firewall?
Not as of yet. No, like I said, I started looking into CVs currently, so that is something I will integrate.
There's multiple organizations. This is how proprietary firewalls will work. There's multiple distros that publish attack signatures, and in real time you can see what attacks are happening in the wild, and you can tune your firewall to block that.
So in terms of, the JS version, it has a G-Shop version configured, and I tried running a sandbox with AIWAF enabled and just no WAF enabled, and then I kind of looked at it. So far it blocks 21 different attack types that I could come up with, all of them, but then there's the question whether it's blocking valid request. So that's what I'm actually working on, and the idea is to get the juice shop in Django and Flask versions as well, just so that anyone looking at the repo has a way to validate as well. So yeah, any more questions?
So it looks at the Nginx logs for training,
Right.
but it doesn't look at anything log-wise from the actual application itself.
Well, it looks at requests as they come in because it's in the middleware. So every request that comes in, it kind of looks at that, and then it also kind of keeps, past 5 minutes worth of request in its cache, and so that it has a context to look at whenever it's blocking anything. Not for header middleware, but for the anomaly middleware especially.
Okay, when you say middleware, does it sit as a separate thing, as a separate resource between like your gateway and your actual application?
So you mean like Django middleware specifically?
Django middleware.
Okay, so yeah, Django middleware is just some extra code that kind of runs in the processing of your requests between like your view function and your generating response.
Yeah, so you add this at your code level then.
Yeah.
Right.
Okay.
So it's in your application. It's not like between that and the.
Okay, but if you want to train it, you still have to
Run.
tell it. You still have to tell it to look at the Nginx log.
Oh yeah, you have to configure that. Otherwise, it will basically say that okay, I don't really have anything to look at. Training
Okay.
done.
Okay, so it's not. It's only middleware at the inference step.
At the inference step,
But during the training, it's no longer middleware.
is no longer middleware.
I see.
So for the isolation forest, you kind of need a training log. Although you cannot do that on request training because that will still take a lot of time. So that is a specific job. I mean, for Python anywhere, all I said it is a task, and then it runs every week, and then it kind of refreshes your isolation forest model. But for that, I don't really have enough logs. And there's actually a specific. So your AI middleware would only work if you have 10K logs. Anything less than that, it will automatically deactivate. The goal is to kind of prevent any false positives, just so that you're not really blocking valid traffic.
So if I wanted to use this, I guess where can I find it?
Pip install AIWAF.
Okay.
Yeah.
Cool.
That will actually change in a few days because I'm trying to consolidate Flask, Django, and FastAPI versions in one repo. So it would be basically pip install AIWAF brackets Django, Flask, or Fast. But yeah.
Question for the room: do any groups have a certain public set of attack payloads that you should be using to test against firewalls, and have the logs come out and say, yes, we blocked because of this rule? I'm pretty sure that they're there, but
There's GitHub repositories that have compilations of attacks.
and with severals that should be true. Okay.
Yeah.
And so my question about logging is that I would want to be able to run these against AIWAF and then to show on logs, all of these were blocked, and they were blocked for the correct reasons, and then take that to someone else, my company, security or whatever, and say, see, this works.
So it does have that level of logging. So if it ends up blocking anything, it will actually log that, but that's additional setup. So you'll have to say create a logging file, and then the logger will automatically log those aspects in.
It's set up the right way. I mean, yeah, that always takes more
Yeah.
time, it's fine.
Yep. Yeah, any other questions? And yeah, I guess I can do a bit of advertising. So we have a PyData meetup coming up as well at Spark. The idea would be to look at noise as a machine learning tool. Yeah. Thank you.